11 vessels. 60 hours. Zero warning. On the night of July 19th, 2026, somewhere in the northeastern corner of the Sea of Azov, the water looked exactly as it always had. Dark. Cold. Unremarkable. A convoy of shadow fleet tankers, running with minimal lighting and suppressed AIS transponders, moved in tight formation toward the Kerch Strait. The Russian naval escort, 2 coastal patrol craft and a single electronic warfare ship, held position 2 kilometers off the starboard flank. Routine. Predictable. Safe. The convoy commander had done this run 14 times since October 2025, 14 times without incident. The northeastern Azov corridor had become what Russian naval planners called a low-friction route. Commercial radar clutter from legitimate grain and steel cargo ships made it nearly impossible for Ukrainian forces to isolate military supply traffic with confidence. That ambiguity was the armor. Or so they believed. What the convoy commander did not know was that 18 days earlier, an operation brief had been authorized at the highest levels of Ukrainian military intelligence. And by the time his tankers entered the northeastern corridor, they had been inside a pre-staged kill zone for nearly 3 days. The operation was called Azov Lattice. By dawn on July 21st, 2026, it had closed an entire maritime corridor. I'm your host at Steel Horizon, where we analyze the battles that change wars. Today we're breaking down one of the most sophisticated naval drone operations in the history of the Ukraine-Russia conflict. A multi-vector Magura V5 strike that eliminated 11 Shadow Fleet vessels in 60 hours and functionally blockaded the Sea of Azov without a single Ukrainian warship ever leaving port. Real battles, real tactics, real consequences. Steel Horizon. To understand why this operation succeeded so completely, we have to go back to early July 2026, and to a pattern that Ukrainian military intelligence analysts had been tracking for nearly 3 months. Russia's Shadow Fleet problem was not new. Since international sanctions tightened in late 2024, Moscow had relied on a rotating pool of aging, flag-of-convenience tankers to move fuel, machine components, and dual-use industrial equipment through the Black Sea and into Crimea's logistics network. The Kerch Strait crossing was the choke point. Everything that supplied the peninsula had to pass through it. But the Sea of Azov itself, that shallow northeastern inland sea, had become the approach corridor. And in the spring of 2026, Russian naval planners had made a calculated decision to concentrate Shadow Fleet transits through the northeastern Azov lane specifically because of its radar environment. The commercial traffic density there was real. Steel exports from Mariupol, still under Russian occupation, generated constant maritime activity. Grain movement from occupied Ukrainian port facilities added more noise. To an external observer, military and commercial traffic blurred together into an undifferentiated mass of AIS contacts. Russian logistics planners had essentially weaponized commercial maritime activity as a cloaking mechanism. Satellite imagery analysis confirmed the pattern by mid-June 2026. Ukrainian General Staff reports, corroborated by OSINT investigations from multiple Western defense analysis groups, showed Shadow Fleet tankers making the northeastern run in groups of 3 to 5 vessels, spacing their transits to coincide with peak commercial traffic windows. The goal was ambiguity. The assumption was that Ukraine lacked the precision strike capacity to isolate and engage military targets inside that radar clutter without risking international incident. Which weapon system was ultimately deadlier in this operation? A HIMARS long-range rocket fire, B conventional shore-based artillery, or C Magura V5 naval drones? Drop your answer in the comments. The results will surprise you. That assumption about Ukrainian limitations was, in retrospect, the most expensive miscalculation of the entire operation. The Magura V5 is a weapon that doesn't get enough attention outside specialist defense circles. It should. The V5 variant. Ukraine's 5th-generation naval surface drone is a semi-autonomous, sea-skimming vehicle approximately 5 meters in length, capable of carrying a 320-kilogram warhead or a mixed payload of explosive charges and sensor packages. Its cruising range exceeds 800 kilometers in favorable sea states. The Azov, at its longest, is roughly 380 kilometers. The Magura V5 can reach any point in that body of water from a staging area well outside visible satellite coverage windows. But the V5's most significant capability advancement over earlier Magura iterations was not its warhead. It was its launch flexibility. Earlier, Ukrainian naval drone operations. The strikes in the Black Sea through 2024 and into 2025 that damaged or sank multiple Russian warships required relatively close coastal launch sites with line-of-sight control relay infrastructure. That created a detection vulnerability. Russian satellite, overwatch, and aerial reconnaissance could, in theory, identify Ukrainian drone staging areas and either strike them preemptively or route convoys to avoid their operational radius. The robo-boat carrier concept eliminated that vulnerability entirely. Here's the part that doesn't make sense on the surface, and yet it worked with extraordinary precision. Ukrainian engineers had developed, by late 2025, a class of semi-autonomous surface carrier vessels, unmanned steel platforms, roughly 12 meters in length, capable of carrying 2 Magura V5 drones, each in a folded, low-radar profile configuration. The carriers used commercial vessel AIS signatures to blend into maritime traffic. They could be pre-staged at any point in the Azov, loiter at minimal power for 72 hours or more, and release their Magura payloads on encrypted command signal. The carriers weren't warships. They didn't look like warships. To radar and satellite imaging, they looked like everything else in that sea. Jorar, Ukrainian military intelligence, had authorized the deployment of 16 carrier vessels in the northeastern Azov corridor beginning July 1, 2026. Each carrier held 2 Magura V5s. Total strike package, 32 drones, pre-staged, loitering, invisible. The operation waited 18 days for the right convoy. Stay with me. What unfolds in the next 18 minutes of this story destroys an entire Russian maritime supply corridor. The intelligence collection that enabled Azov Lattice is worth examining in detail because it shows how far Ukraine's ISR architecture has evolved since 2022. By the summer of 2026, Ukrainian military intelligence was operating a layered reconnaissance system over the Sea of Azov that combined commercial satellite imagery from at least 4 providers, signals intelligence intercepts from forward-deployed collection assets near the Azov coastline, and, crucially, data from a network of passive acoustic sensors that Ukrainian naval engineers had deployed across the northeastern shipping lane in 3 separate covert operations between November 2025 and February 2026. The acoustic sensor network was the decisive intelligence advantage. These devices, resting on the Azov seafloor at depths averaging 8 to 14 meters, could detect and classify vessels by their propulsion signatures with a high degree of accuracy. Shadow fleet tankers, many of them aging Soviet-era designs with poorly maintained propulsion systems, generated distinctive acoustic profiles. When a vessel matching a known shadow fleet signature entered the northeastern corridor, the sensor network logged the transit time, speed, heading, and, critically, the spacing between vessels and convoy. That spacing data told Ukrainian planners something satellite imagery alone could not: how the Russian naval escort was positioning itself relative to the cargo vessels. The escort pattern, logged across 14 prior transits, showed that Russian patrol craft consistently maintained their 2-kilometer standoff position to the starboard side of the convoy. They never varied. 14 transits, same pattern. Soviet-era tactical doctrine executed with mechanical consistency. Then came the first obstacle that threatened to unravel the entire operation. On July 14, 2026, 5 days before the planned strike window, one of the 16 carrier vessels experienced a propulsion system failure in the southern sector of its assigned grid position. The vessel's position drifted approximately 4 kilometers outside the intended corridor coverage zone. Ukrainian operators detected the failure within 90 minutes, but the immediate options were limited. Sending a surface vessel to recover or reposition the carrier risked exposing the operation to Russian maritime patrol aircraft conducting irregular reconnaissance flights over the northeastern Azov. Leaving the carrier in its drifted position created a gap in the southwestern strike arc. The GUR operations team made a rapid decision: redistribute the targeting assignments for 4 neighboring carrier vessels, extending their individual coverage arcs by approximately 600 meters each. The southwestern arc gap remained, but its coverage was reduced from 4 kilometers to under 1 kilometer. For a convoy running in tight formation, that margin was calculated as acceptable. It was a decision made under pressure, in darkness, with imperfect information. That it worked speaks to the quality of the operational planning that had preceded it. By July 17, 2026, acoustic sensors confirmed what Ukrainian intelligence had been anticipating for nearly a week. A convoy assembly was underway near the port facilities east of Mariupol. 11 vessels, 9 Shadow Fleet tankers, and 2 industrial cargo ships carrying components assessed as dual-use manufacturing equipment were being staged for a coordinated transit. The estimated departure window was the night of July 19th to 20, timed to coincide with a predicted weather system that would reduce aerial reconnaissance effectiveness. Russian naval planners apparently believed that the combination of radar, clutter, darkness, marginal weather, and their consistent 14 transit undetected record made this run acceptable risk. I spent considerable time working through the intercepted communications timeline that Western defense analysts later reconstructed from this operation, and one detail kept surfacing, something that shows exactly how confident Russian commanders were going into that night. The convoy's naval escort commander sent a routine transit report at 9:47 p.m. on July 19th, 4 hours before his vessels entered the primary engagement zone. The report was optimistic. Standard language, standard routing confirmation, standard ETA to Kerch. No heightened alert status. No request for additional air cover. The escort had conducted its pre-transit sweep, visual and radar, and detected nothing unusual in the corridor ahead. Of course, the carrier vessels looked like nothing unusual. That was the entire point. How many Russian vessels did Ukraine's Magura drones strike during Operation Azov Lattice? A-7 vessels, B-11 vessels, or C-14 vessels? Hold that number in mind. We'll give you the confirmed assessment with full breakdown at the end of this video. At 1:23 a.m. on July 20th, 2026, the GUR Operations Center issued the activation signal. 32 Magura V5 drones, carried across 18 days of silent loitering by 16 autonomous carrier platforms distributed across a 40-kilometer grid, received their targeting packages simultaneously. The drones deployed from their carriers in a sequence that had been precisely choreographed. First, the drones assigned to the northern arc, then the eastern arc, then the repurposed southwestern coverage. A staggered launch window of approximately 4 minutes total that ensured no 2 drones from the same carrier would arrive at their assigned target at exactly the same time. This sequencing was deliberate and tactically significant. A simultaneous multi-drone approach from a single vector is detectable and potentially jammable. Electronic warfare systems. Russia's were aboard the escort ship, the Naval, a Vishnya-class intelligence vessel that had been modified with additional jamming packages, are designed to identify drone control signals and either disrupt the command link or spoof the navigation data. The Magura V5 had been specifically upgraded, per Ukrainian Defense Ministry disclosures made in early 2026, with a fiber optic control redundancy system that maintained command link integrity even under active jamming conditions. But GUR planners weren't relying solely on the fiber optic backup. The multi-vector, staggered approach meant that even if the Naval's jamming systems neutralized some drones in the eastern approach arc, drones arriving from the northern and southwestern arcs would not be using the same control frequencies. It was a saturation strategy built on frequency diversity and geometric complexity. Russia's electronic countermeasures could handle one attack vector. They could not handle 3 simultaneous approach geometries with staggered timing and frequency separation. Put yourself in the position of the Russian escort commander at 1:31 a.m., 8 minutes after the Magura swarm began its approach runs. His radar picture is showing contact returns at the edge of reliable detection range in multiple sectors. The returns are small, sea-skimming, fast. The escort's electronic warfare officer is reporting jamming signal detections but can't establish a clear jam footprint because the signal sources are spread across a 40-kilometer arc. The EW ship is attempting to respond, but its jamming power is concentrated. It can suppress a narrow frequency band in a specific direction, not 3 directions at once. The convoy commander issued a hard turn order at 1:33 a.m. Standard evasion protocol. Alter course, increase speed, close formation. What the protocol did not account for was the fact that the drone grid had been pre-calculated to cover exactly the kind of evasion maneuvers that standard Russian naval doctrine specified. The targeting coordinates were not fixed points in the water. They were predictive intercept solutions, updated in real time by the drone sensors themselves. The convoy turned. The drones adjusted. The geometry held. At 1:37 a.m., the first Magura V5 struck the lead tanker of the convoy, a vessel later identified by OSINT investigators as the Fortuna Star, a 12,000 deadweight-ton Shadow Fleet tanker operating under a Palau flag of convenience. The warhead detonated at the waterline on the port bow, generating a shaped charge blast designed to penetrate the hull below the waterline rather than detonate above deck. The Fortuna Star took on water immediately. Structural damage to the forward cargo hold was severe. Within the next 11 minutes, 9 additional strike events were confirmed by Ukrainian drone sensor data. The Naval, the Russian electronic warfare ship, was not struck in the initial wave. It was struck at 1:44 a.m., separately, by a Magura V5 assigned specifically to the escort vessel. The drone operator's log later showed that the V5 targeting the Naval had approached on a bearing that kept the vessel's own superstructure in the sensor's ground clutter layer, essentially hiding the drone's approach signature behind the ship it was attacking. The Naval was struck midships. The explosion disabled its main power systems. The jamming equipment went offline at 1:44 a.m. and 7 seconds. By 2:15 a.m., Russian Naval Command in Kerch had received fragmented reports from 3 vessels. The reports described chaos, multiple fires, at least 2 vessels dead in the water. The convoy formation had broken apart, ships attempting individual evasion maneuvers, most of which were complicated by the darkness and the marginal weather that Russian planners had counted on as protective cover. The weather that was supposed to suppress Ukrainian aerial reconnaissance instead prevented Russian rescue and escort vessels from making rapid transit to the engagement area. Intercepted Russian naval communications, later shared with Western defense analysts, showed the convoy's senior officer requesting air cover at 2:19 a.m. The response from the Regional Aviation Command took 11 minutes to arrive. When it did, the answer was negative. No fixed-wing assets were available for immediate deployment at that hour with the weather conditions over the strait. Helicopter assets were available but restricted to the immediate Kerch Strait area by the same weather system. The air cover never came. What this phase of the operation reveals is a systemic gap in Russian maritime doctrine. Russian naval planning, as documented throughout this war, treats convoy escort as a checklist function rather than a dynamic threat response system. The escort was positioned, the EW ship was present, the patrol craft were on station. The box was checked. But the escort doctrine had been designed to counter threats that a 2010-era naval staff had considered relevant. It hadn't been updated to account for a distributed, carrier-launched, multi-vector drone swarm operating from pre-staged positions inside the convoy's own corridor. This is the real lesson Moscow dismissed as impossible. Ukraine had moved the battle inside Russia's defensive perimeter before the battle started. The 11th vessel, one of the industrial cargo ships, was struck at 3:52 a.m. on July 20th, nearly 2.5 hours after the initial engagement. The delay was not a failure. It was a function of that vessel's evasion maneuver having taken it outside the initial engagement zone. A reserve, Magura V5, held back specifically for this contingency, was directed to the updated intercept solution. The cargo ship was struck on the starboard quarter, sustaining significant damage to its aft engineering spaces. By 6:30 a.m. on July 20th, Ukrainian General Staff reports confirmed 11 vessels struck. Of those, 3 were assessed as total losses, sinking or sunk within the engagement zone. 5 were assessed as severely damaged with unknown capability to continue under their own power. 3 sustained moderate damage. The Naval was assessed as mission killed. Her jamming and intelligence systems disabled, her power plant requiring extensive repair. By any measure, this was not a contest between equal forces. It was the systematic erasure of a logistics convoy by a pre-staged, intelligently distributed strike system that the target never had a realistic chance of defeating. Here's the take that will probably generate some argument. Russian naval leadership should have recognized by early 2026 that the northeastern Azov corridor was untenable as a primary supply route. The acoustic sensor network deployment operations that preceded Azov Lattice, 3 separate covert missions between November 2025 and February 2026, were not perfectly concealed. Russian intelligence had indicators that something was being deployed in that seafloor environment. The decision to keep routing Shadow Fleet traffic through a corridor that showed signs of Ukrainian sensor interest was not a calculated risk. It was institutional denial. The 14 successful transits created a false sense of invulnerability that led directly to the loss of 11 vessels in 60 hours. Subscribe to Steel Horizon if you want to understand how modern warfare actually works, because what this operation demonstrates goes far beyond the Sea of Azov. The full 60-hour dimension of this operation is worth examining, because the strikes did not stop on the morning of July 20th. The GUR operations team had anticipated that the first wave of strikes would trigger a Russian response, specifically an attempt to route emergency resupply through the central Azov corridor rather than the northeastern lane. The carrier grid had been designed with exactly this contingency in mind. 4 carrier vessels, positioned in the central Azov, had been held in reserve through the initial engagement. Their activation came at 11:15 p.m. on July 20th, when acoustic sensors and satellite imagery confirmed that 2 Russian coastal patrol craft and a single auxiliary cargo vessel were attempting a rapid transit through the central corridor. The cargo vessel was carrying, by Ukrainian intelligence assessment, fuel and ammunition components bound for Crimea's garrison logistics network. The reserve drones were activated. 2 Magura V5s reached the cargo vessel at 12:08 a.m. on July 21st. The patrol craft attempted jamming and evasion. 1 patrol craft sustained light damage from a near-miss detonation. The cargo vessel was struck twice, sustaining damage assessed as severe. She was left dead in the water 50 kilometers northwest of the Kerch Strait entrance. The second patrol craft turned back. The central corridor transit was abandoned. By the morning of July 21st, 2026, 60 hours after the initial Azov Lattice activation signal, Russian maritime logistics to Crimea through the Sea of Azov had effectively ceased. The northeastern corridor was blocked by damaged and sinking vessels, creating a navigation hazard. The central corridor had been demonstrated as equally vulnerable. Russian Naval Command in Kerch issued an emergency routing suspension for all Shadow Fleet traffic through the Azov pending threat assessment. As of July 24, 2026, that threat assessment had not resulted in any publicly disclosed routing resumption. One detail from the intercepted communications records stayed with me through the full analysis of this operation. At 4:37 a.m. on July 20th, a Russian naval officer transmitted a single brief message to the regional command net. Translated from Russian, it read approximately as follows: "We cannot see them. We cannot stop them. We cannot call for help. Request guidance." The response from regional command came 42 minutes later. It was administrative in nature, a request for a standardized damage report in the prescribed format. The officer requesting guidance received a form to fill out. The doctrine shift that Azov Lattice represents is the one Moscow had declared categorically impossible as recently as the spring of 2026. Russian naval analysts had publicly assessed, in open-source strategic journals that Western intelligence services certainly read, that Ukraine's naval drone program was fundamentally constrained by the need for coastal launch infrastructure. The reasoning was logical by 2022 standards. Drone control requires communications relay, relay requires proximity, proximity requires coastal access, and coastal access is a known fixed variable that can be monitored and targeted. The Robo-Boat carrier grid invalidated every step of that reasoning chain simultaneously. Ukraine no longer needs a coast to launch a naval strike. The carriers are the coast. The carriers move. The carriers look like everything else on the water until the moment they don't. If you believe tactics win wars, type Steel Horizon in the comments. Because the tactical lesson of Azov Lattice is not simply that naval drones are powerful. That's been established for years. The lesson is that the delivery architecture matters as much as the weapon itself. Robo-boat carriers turn any body of water into a potential launch platform. The Azov was first. It will not be the only theater where this doctrine is applied. What would NATO's maritime doctrine have suggested doing differently in Ukraine's position? Comment your tactical analysis below. We read every response, and some of the best ones inform future Steel Horizon breakdowns. For Russia's Crimea supply chain, the loss of 11 vessels and the closure of the Azov corridor in 60 hours is not merely a tactical problem. It is a structural one. The peninsula's garrison requires a continuous flow of fuel, ammunition, and industrial components. The Black Sea route through the Kerch Strait remains available, but it is exposed to longer-range Ukrainian strike systems. Storm Shadow, cruise missiles, HIMARS, GMLRS, extended-range munitions, and the broader naval drone threat. The Azov corridor had functioned as a lower-risk alternative. That alternative is now gone. Ukrainian Defense Ministry officials, in statements to Western defense correspondents in the days following the operation, were characteristically understated. The operation achieved its objectives, a senior GUR official told one briefing. The corridor is closed. No specific casualty figures for Russian crews were disclosed. No celebratory announcements. Just the cold arithmetic of closed shipping lanes and maritime traffic patterns that, as of July 24, 2026, shows zero shadow fleet transits through the northeastern Azov. Most analysts focused on the drone technology after this operation. That's the wrong angle. The technology was mature by early 2026. What changed was the deployment architecture. And that shift is far harder for Russia to counter than any single weapon system upgrade. Will Russia develop an effective countermeasure to the robo-boat carrier concept within the next 12 months? Comment yes or no, because the answer shapes everything about the next phase of this maritime campaign. Now, the answer to the tactical question posed earlier. How many Russian vessels did Ukraine strike during Operation Azov Lattice? The correct answer is B-11 vessels, confirmed by Ukrainian General Staff Assessment, corroborated by satellite imagery analysis from commercial providers and OSINT vessel tracking data that showed 11 specific AIS contacts going dark or showing severe anomaly patterns within the 60-hour engagement window. Of those 11, 3 Shadow Fleet tankers were assessed as total losses. 5 vessels sustained severe damage requiring tow assistance. 2 vessels sustained moderate damage. The electronic warfare ship Naval was assessed as mission killed. A 12th vessel, the cargo ship struck in the second wave Central Corridor operation, brings the full 60-hour operational tally to 12 damaged or destroyed. Ukrainian sources estimate the total monetary value of vessels and cargo lost or damaged at between $280 and $340 million. Against that, the Robo-Boat carrier grid, the Magura V5 payloads, and 18 days of pre-positioning. The asymmetry is the story. 3 questions that demand honest analysis. Was the GUR decision to proceed despite the July 14th carrier malfunction and the resulting arc gap the right call? The gap reduced southwestern coverage from 4 kilometers to under 1 kilometer, a margin that, in a different convoy routing scenario, could have allowed vessels to escape. The decision was operationally justified by the intelligence picture. But a tighter convoy formation or a slightly different heading could have exposed that call as a critical error. Could Russian Naval Command have prevented this with the information they had? The indicators were present. 3 covert Ukrainian sensor deployment operations over 4 months, anomalous acoustic activity in the northeastern corridor, and the broader strategic context of Ukraine's demonstrated willingness to reinvent its strike architecture. The 14 successful prior transits created a normalcy bias that proved fatal. What would you have done differently commanding the Russian escort on the night of July 19th? 2 patrol craft, 1 EW ship, radar contacts appearing simultaneously from 3 separate bearings, 4 minutes before first impact. Subscribe to Steel Horizon, because we break down the battles that textbooks will study for decades. Not just what happened, but why it happened, how it unfolded, and what it means for every conflict that follows. Real tactics. Real consequences. Steel Horizon. The Sea of Azov is quiet now, but 11 vessels sit damaged or on that seafloor, silent reminders that modern naval warfare punishes tactical complacency without mercy. The robo-boat carriers have returned to their staging areas. The Magura drones are being reloaded. And somewhere in the northeastern corridor, the acoustic sensors continue to listen. Stay vigilant.